Hello and welcome to another live stream, another half-term revision live stream. Today I thought we could tackle some ratio problems. So I have some problems on the screen. Before I get into those, yesterday we did some vectors, today we're doing ratios, and again, still planning on doing a live stream every day this week. So let me know what topics you'd like me to go over. If you need some help with anything, if you want to pop into a live stream, do you need help on any particular topics? Do you have some problems that you're having trouble with? Let me know in the comments. If you want some, maybe just some extra motivation to get going on a particular mathematics topic. So yeah, leave a comment or something in the chat or send me an email. All the information's in the description. And as I said yesterday, the better your question is, the better the answer you'll get. The other thing I wanted to mention was the Research Institute Christmas lectures are now up on YouTube. So if you want something to watch in the half-term break, check out the Research Institute Christmas lectures. They're really, really good. And I'm going to be doing a bit of a review of those. I've watched the first two. I've watched the first two Christmas lectures. Still have to watch the third one, then I'm going to do a bit of a review. Hey Blue Snow, welcome. Hey Olaf Fusi, welcome. As I was saying, the first two Christmas lectures are really good. Check them out if you want something to watch. If you like, it's entertaining. It's not, hard mathematics. Like, it's not like mathematics homework. It's entertainment, mathstainment, edutainment kind of thing. So yeah, check out those Christmas lectures. And also you might learn something as well. Okay, so was there anything else before I want to get started? I think that was everything. Alright, let's get into these ratio problems. And while I'm going through it, I'll have some time. I might not go through all of them, but I will have some time towards the end to go through some topics if you want to shout them out. If you're tuning in and you want to go over something that you're struggling with, then I'll have some time at the end to go over that. So yeah. Okay, let's get into it. Hello Daily Football, hello Joy, hello Auntie. Okay, ratio problem solving. Hopefully these are interesting problems to you. They're not super hard, but they're still challenging, hopefully. So let's see how we go. Okay, so first one says, I have three types of shapes: triangle, squares, and circles in the ratio 3:6:1. The triangles are either red or blue. The ratio of red triangles to blue triangles is 4:5. Given that I have 12 red triangles, how many circles are there? Okay, so let's firstly write down the first one. I might use shapes to represent them rather than letters. So I've got a triangle to a square to a circle, and I'm going to color it in so it's like an O. This equals 3:6:1, and then they tell me that the ratio of red triangles to blue triangles is 4:5. Okay. And they tell me how many red triangles there are. So if there are 12 red triangles, one way you can do this is to rewrite this ratio so that the number representing red triangles is the amount that you have. So what could I do to this ratio to create or to turn that into a 12? Could multiply it by 3. So this would be 12 to 5 times 3 is 15. And now that the number relating to red triangles is the actual number of red triangles there are, that means this number also represents the number of blue triangles. So I have 12 red triangles, 15 blue triangles. Now let's go back to our original ratio to work out the number of circles. I'm excited I haven't done barely anything today. Awesome. Good. Hopefully this motivates you. Let's get a little bit of work done. Well, how many triangles in total do I have? If I have 12 red triangles and 15 blue triangles, I have 27 triangles. Okay, how does that relate to this 3 in this ratio? Well, that means one part of that ratio must be 9, because 3 times 9 is 27. So if one part of this ratio equals 9, that means I must have 9 circles. Okay, so that's my answer here. So for part 1 or question 1, I have 9 circles. Okay, on to question 2. Let me know if these get a bit repetitive. I can skip to the last few. They're a bit harder. So welcome Phoenix Flames. Could you go through the one before the last question, 2019 paper 1? Okay, yep, towards the end I could bring that up. Okay, question 2 says, in my house, the ratio of dogs to fish is 1 to 10. The ratio of fish to cats is 6 to 1. What is the ratio of dogs to cats? Okay, this is a fairly standard sort of ratio question, but it's something you really do need to master because it's the type of skill that comes up in harder questions. So dogs to fish, 1 to 10, fish to cats, 6 to 1. The common element in those two ratios is fish. I want that number to be the same in both ratios. So you can either multiply the 10 by 6 or look for the lowest common multiple of 10 and 6. I would suggest looking for the lowest common multiple because you'll end up with easier, it's good practice in other words. So if, for example, if this was 14 and 28, you don't want to multiply 14 and 28. You want to see that 14 goes into 28 and you only need to multiply 14 by 2. So looking for the lowest common multiple is a better strategy here. So the lowest common multiple of 10 and 6 is 30. Well done, James Cook. Multiply this one by 3. Multiply this one by 5. This will be 30 to 5. And then, because the common element in both ratios is the same, I can write this as dogs to fish to cats as 3 to 30 to 5. Okay, my writing got a bit messy there, but 3 to 30 to 5, and then the question, remember, is saying what's the ratio of dogs to cats? Well, then you can just leave the F out. Dogs to cats will be 3 to 5. Final answer there. 60. So 60 would not be the lowest common multiple, it would be a common multiple. So not the lowest one. Yeah, you could use 60. So you could do 6 to 60 and then 60 to 10. It would still work. Here you just end up with, you'd firstly have, what do we say, 6 to 10, and then you'd have to simplify that. Okay, on to the next question, question 3. The ratio of rabbits to guinea pigs is in a shop is 2 to 7. Okay, so let's write down rabbits to guinea pigs, 2 to 7. The ratio of brown rabbits to grey rabbits is 2 to 3. Okay, so let's say BR for brown rabbits, GR for grey rabbits, 2 to 3. What is the fraction of the animals in the shop that are grey rabbits? Okay, we're bringing fractions in here. So always notice, be careful of the wording in these ratio type questions. Be careful when they say fraction or proportion or ratio. You have to be aware of the differences there. So I have a ratio of rabbits to guinea pigs 2 to 7 and a ratio here. The number of parts here, 2 plus 3 is, total parts is 5. So then I need that ratio, if you like, to fit into this ratio, these two parts. So what's the relationship between 2 and 5? Again, we're looking for a common multiple. Well, that would be 10. So what I want to do is multiply this ratio by 5. 2 times 5 is 10. 7 times 5 is 35. And also want this one to add up to 10. So multiply this by 2. This will be 4 to 6. And now that these numbers add up to the parts of the rabbit, then we can write this as brown rabbits to grey rabbits to guinea pigs equals 4 to 6 to 35. And so going back to the question, what fraction of the animals are grey rabbits? Then you need to know how to convert from a ratio to a fraction. Take the number in that ratio, and that's the numerator. The denominator is the total parts in that ratio. So 4 plus 6, 10 plus 35, I should say, 45. Then we can simplify that. Divide by 3. 3 goes into 45 15 times, 2 over 15. That makes me think there would be a simpler way to do that if the final answer is 2 over 15. Not sure. Anyway, that's my method. If you saw a better way to do that, then awesome. Question 4. Question 4 says, the ratio of daisies to fuchsias in my garden is 2 to 3. The ratio of fuchsias to roses is 10 to 3. What is the ratio of daisies to fuchsias to roses? That's pretty similar to the last 3. I might skip that one. On to question 5 actually. I'll leave question 4 for you if you want to give that a go. Question 5 says, I'm choosing shapes out of a bag. The ratio of blue shapes to red shapes is 2 to 1. Oh, thank you for the likes, by the way. That's awesome. Some likes on there already. Really appreciate that. Blue to red shapes is what I was up to reading. So you notice I write the information down as I go. Sometimes I like to do that so I don't have to reread it. Sometimes I write it afterwards. That's a different strategy to answering these worded questions. For the blue shapes, the ratio of spheres to cubes is 2 to 3. So we've got blue spheres to red spheres. Sorry, blue cubes. Blue cubes is 2 to 3. For the red shapes, ratio of spheres to cubes is 1 to 4. Okay, so red spheres to blue, again, what am I saying? Red squares, red cubes is 1 to 4. Given that there are 12 red spheres, how many blue cubes are there? Okay, so, well, this is like a sort of similar to what we did for question 3, but now we have 2 ratios that we want to fit into this original ratio. So I have 5 parts here, 5 in each actually, but I have double the number of blue shapes. So what we could do here is to multiply this ratio by 2, because I've got twice as many. So multiply each by 2, this will be 4 to 6, and leave the ratio of the red shapes as is, and then I could write this as, okay, yeah, let's write this out again. Blue spheres to blue cubes to red spheres to red cubes as 4 to 6 to 1 to 4. And oh, I didn't actually need to do it. Well, it kind of makes the explanation a bit easier. So this is my ratio of all of the different shapes I have, including the colors. And if they tell us there are 12 red spheres, that's a 1 part in this ratio. blue cubes is 6 parts in this ratio, so that's going to be 6 times 12. 6 times 12 is 72. So final answer there for question 5 would be 72 blue cubes. Okay, and I'll go through and check all these answers at the end, just to make sure I'm not making any mistakes. Okay, up to question 6. Hello. I think I missed a few things. Welcome, Inno tutorial. Addy, why did I times it by 2? This one here, the blue shapes. Yeah, because of the initial ratio, they tell us there's two times as many blue shapes. Going back to the question, they say the ratio of blue shapes to red shapes is 2 to 1. That means there's twice as many blue shapes, so we can multiply this ratio by 2, and that effectively does the same thing. Okay. Question 6. Watching maths while on a break from maths. Question 6 says, in a school, 55% of the pupils are girls. Out of the girls, the ratio of ones with blonde hair to the ones with brown hair is 2 to 3. What percentages of pupils are blonde girls? Blonde girls? Blonde-haired girls? Okay. Anyways, so we're given an initial percentage. So we've got girls equals 55%. I was just thinking, break from maths. What do you mean break from maths, Code Dragon? You don't have a break from maths. Sorry. Anyways, then they tell us the blonde, so let's write BL for blonde and BR for brown. That's 2 to 3. So what percentage of pupils are blonde-haired girls? I'm guessing we have to assume there are only girls with blonde hair and brown hair. Because what if there were girls with black hair? Then you can't figure this out. So I'm assuming there are only girls with blonde hair or brown hair. So the proportion or the fraction of girls with blonde hair is 2 out of the total. So 2 out of 5. And then we want 2/5 of 55% to work out the percentage of all of the pupils with blonde hair, of girls who have blonde hair. So this is like a percentage of a percentage or a fraction of a fraction. You can multiply that fraction by the percentage. Another way of writing 55% is 55 over 100. This is GCSEs, yeah. I should probably write that in the title next time. Yep, 2/5 times 0.55, or I probably wouldn't think about it that way without a calculator, but yeah, you're exactly right. I would probably do 55 divided by 5, which is 11, and then 2 times 11. So I'm cancelling here, and then 2 times 11 is 22 over 100 is 22%. Excuse me, just getting a drink. On to question 7. Yeah, question 7's a bit different. So question 7 says the ratio of lipsticks to eyeshadow in my makeup bag is 1 to 9. The ratio of eyeshadow to mascara is 3 to 1. Given that I have 3 more eyeshadows than mascaras, how many lipsticks do I have? So lipstick to eyeshadow, L to E, equals 1 to 9. Eyeshadow to mascara is 3 to 2. Grade, I would say this is probably 7 to 8, like some of the questions I'm going to get into down here, I would say are up to grade 8. I wouldn't say there's any grade 9 questions in this list. Yeah, it's difficult to write a grade 9 question, that's for sure. Okay, so given that there are 3 more eyeshadows, well, looking at this ratio, E to M, how many more parts in that ratio are eyeshadows than mascara? Grade 5, okay, well, yeah, some of them. I mean, I'll get into some in a minute that are a bit more difficult. Eyeshadow to mascara, that's what I was looking at. So how many more parts of eyeshadow do I have? 1 more part of this ratio. So if there are 3 more eyeshadows than mascaras, that means 1 part of this ratio equals 3 objects, 3 eyeshadows. So if 1 part is 3, that means in this ratio I have 9 eyeshadows, or in the bag I have 9 eyeshadows. So then how many lipsticks do I have? If I've got 9 eyeshadows, I've got 1 lipstick. Okay, so that question is about recognizing how to take this information when you're told you have 3 more or a certain amount more of something, and putting that in the context of a ratio. That question, yeah, that would probably be grade 5, 6, possibly. Upper, that could possibly even appear in a foundation paper. Question 8. I'm not awesome at recognizing grades, I have to be honest. I do recognize a challenging problem, but I'm not awesome yet at kind of saying that's a grade 5, that's a grade 8. I'm not that specific. I can just kind of say, okay, that's upper level, this is middle, type of thing. PDF, I'll put it in the description at the end. I don't actually have a link for that at the moment. Okay, that was question 7. I got 1 lipstick. Question 8, I have a box of chocolates with white, milk and dark chocolates in. The ratio of white to not white is 3 to 4. The ratio of not dark to dark is 17 to 4. What is the ratio of white to milk to dark? Alright, let's go on to this page here. So the ratio of white to not white, so milk plus dark, is 3 to 4. Suraj, you've done these before. Yeah, you might have seen these before. The ratio of not dark to dark is 17 to 4. So this would be white plus milk to dark equals 17 to 4. Right, so they've given us 2 ratios and they're asking us to find the ratio white to milk to dark. Now, the way that this is set up, I would probably approach this with an equation. I would set up some equations and solve it kind of algebraically. That would probably be my approach. There's different ways of doing this, but that's the way I'm going to take for this particular question, I think. So writing the first ratio as an equation, you would write, for my first one, I would write W over M plus D equals 3 over 4. And then rearrange this, so this would be 4W equals 3 times M plus D. Okay, and then writing this as an equation, this would be W plus M. So white plus milk over dark equals 17 over 4. Then rearranging this, I would have 4 times white plus milk equals 17D. And expanding those brackets, 4W plus 4M equals 17D. And then what I would do is, well, this was my second equation. Actually, let me change the colors here. This was my first one. This was my second equation. Taking the first equation and substituting it into the second, I would take this part and substitute it in for 4W here. Okay, so I'm taking equation 1 for 4W and substituting it in here where this 4W is. So then I have 3M plus D plus 4M equals 17D. And now I've eliminated one variable, so I'm going to get a ratio of M to D, which will allow me to write this ratio that I'm looking for, white to milk to dark. So simplifying this, this will be 3M plus 3D plus 4M equals 17D. And then 7M equals 17D take 3D is 14D. And then as a ratio, you could divide by D, divide by 7, you would get M over D equal to 14 over 7. So that's still an equation, but you could write this as a ratio M to D equals 14 to 7 or 2 to 1. Okay, so ratio of M to D is 2 to 1. I still have some work to do because I still have this first ratio here. I'll write that down below, that I need to kind of work with as well. So if I know that M plus D equals 3 to equals 4 parts of this, I need the lowest common multiple of 3 and 4, which is 12. So multiply this one by 3, I'd get 9 to 12. Multiply this one by 4, I get 8 to 4. So now that 8 plus 4 equals 12, I can write this as 9 to 8 to 4. And that would be the final answer of white chocolate to milk chocolate to dark chocolate. Okay, there's an example of a slightly more challenging question. Not 100% sure if that's the only way to answer it. Perhaps there's a different method, but there you go. That is one possible way to answer that question. So final answer, 9 to 8 to 4. Question 9. Okay, yeah, let's do the last 3. They're kind of similar to what we've already covered, but might as well. It's good practice. Okay. Question 9 says, I'm on a farm with pigs and horses. The ratio of pigs to horses is 4 to 1. Okay, P to H equals 4 to 1. 9 to 8 to 4. Okay, yeah, I can go over that again quickly. So, this was the ratio here of milk. Excuse me. This was the ratio of milk to dark chocolate, 8 to 4. I changed this equation, white chocolate to milk plus dark chocolate, from 3 to 4 to 9 to 12. And then split this ratio of milk to dark into 8 to 4 to get that final one. Okay, on to question 9. The ratio of pigs to horses is 4 to 1. The ratio of adult pigs to piglets is 1 to 5. Okay, so we're talking about babies. Oh no, sorry. Pigs. We're talking about pigs. And we've got adults to babies for the pigs is 1 to 5. For horses, we have adults to babies of 3 to 1. And what is a fraction of the farm? What fraction of the farm are babies, foals, and piglets? Okay. So again, okay. So this is similar to question, which was it? Question 5. So we need a similar approach here. We need to fit these two fractions into these. So I want a common multiple of 4 and 6, and also a common multiple of 4 and 1. Okay, so it's a little bit more difficult. So in other words, the second number in this ratio needs to be a multiple of 4. So it's not going to be 6. If I multiply this by 6, I'd have 6 here. So I can multiply by, if I multiply by 12, that would be 48. And that would be also a multiple of 6. Okay, I'm going to go with 12. So 4 times 12 is, oh yeah, the number I'm multiplying by needs to be a multiple of 6 and 4. That's the key. So yeah, again, 4 times 12, 48. 1 times 12 is, why did I write 4 there? I meant to write 48. 1 times 12 is 12. And then we could write this as adult pigs to piglets. We need to firstly multiply this by 8. So this would be 8 to 40. And multiply this one by 3. This would be 9 to 3. And then they all add up. So then the ratio would be 8 to 40 to 9 to 3. Okay, so that's the ratio of adult pigs to piglets to adult horses to foals. And then we're looking for the fraction of the farm are babies. What fraction of the farm are babies? So which ones? These were the babies. So 40 plus 3. Made a mistake. Anyway, I think this should add up. Okay, so 48 plus 12 is 60. Alright, 43 over 60 is my final answer. Let me know if I made a mistake adding those up. That's my final answer, 43 over 60. Next, answers, don't want to see the answers yet. Question 10. How's it going in the chat? I haven't read. I keep looking over and I see people saying, oh, are these foundation questions? I don't know. They are middling difficulty and good ratios practice, I think. So really open to anyone. If you're looking for really higher tier grade 9 ratios questions, these are probably not quite that difficult, but still I think good practice if you feel you need practice with ratio. It never hurts to work on these types of questions, these types of worded problem-solving questions. Okay, question 10. On a table there are some sandwiches. The ratio of sandwiches with white bread to brown bread is 10 to 3. Out of the sandwiches that are white, 2/3 are vegetarian. Out of the sandwiches that are on brown bread, half are vegetarian. What fraction of the sandwiches are vegetarian? Okay, so we have an original ratio of white to brown of 10:3, and 2/3 of those are vegetarian. So for the white bread, we have veg to non-veg, I guess. That would be the other alternative, non-vegetarian. This equals 2/3. So here you need to know how to convert from a fraction to a ratio. Yes, Zara, this is ratios, working on some ratio problem solving. How do I convert from 2/3 to a ratio? Well, remember the denominator of the fraction is the total part in that ratio. So it's not going to be 2 to 3 because the parts need to add up to 3. The ratio is going to be 2 to 1. Okay, for the brown bread, we have veg to non-veg. Awesome, Blue Snow. Glad you found that helpful, if you're talking to me. Half, if they tell you half are vegetarian, how do I write that as a ratio? If they tell you half of something is vegetarian, how would they represent that as a ratio? Give this one a go. Okay, it's going to be 1 to 1. Okay, so I have the two ratios. What fraction of vegetarian? I need to, again, similar approach to part 9 and question 5. I need to write this as white veg and non-veg to brown veg and non-veg. I want to represent these all in one ratio. Okay, so I'm looking for I'm looking to create what? A multiple of 3 and a multiple of 2. Or that's 6, right? So multiplying this by 6, I'd get 60 to 18. Okay, so white to brown bread sandwiches are 60 to 18. Then I need to multiply this one by 20. 3 times 20 is 60, so this would be 40 to 20. And multiply this one by 18, so this would be 18. Sorry, not. It needs to add up to 18, not multiply by 18. So multiply this one by 9. This would be 9 to 9. So then this ratio is 40 to 20 to 9 to 9. Maggie Louie, Maths Explained and Free Science Lessons on the Legends of GCSEs. Convince me otherwise. Too kind. Way too kind. Thank you, though. Okay, so what are we looking for? The fraction that are vegetarian. Well, I have this final fraction, 40 to 20 to 9 to 9. What parts of those are vegetarian? It's this one and this one. So then I add those up, 49, and add the total. That would be the denominator. 60 plus 18, that's this one here, that's 78. And I can't simplify that because the only factors of 49 are 7, and 7 doesn't go into 78. So that doesn't simplify. Okay, last of these questions that I'm going to do. Let me know if you want me to go through some things you're suggesting in the chat. Could go through a few questions that you have if you would find that useful. So have a think while I'm going through this one. Question 11 says the ages of Adam, Ben and Caleb are in the ratio 5 to 7 to 11. Next year they will be in the ratio 8 to 11 to 17. How old are they all now? Okay, so Adam to Ben to Caleb, we can write that as A to B to C. That's 5 to 7 to 11. And after 1 year, so next year, they'll have the ratio A to B to C equal to 8 to 11 to 17. So this was after 1 year. 1 year later. All right. Have a think how you might go ahead and solve this. What would be your approach here? How would you start this out? So my mind goes to equations in algebra. That's kind of, I don't know, maybe that's the way I'm wired or something, but that's what I think of when I see a problem like this. And I want to say that if I multiply, well, firstly, obviously their ages are not actually 5, 7, and 11. Because if we add 1 to those, we wouldn't get this ratio. We'd get 6 to 8 to 12. And that's not what we have here. So these are not their actual ages. We'd get their actual ages by multiplying by some factor. And we could call that x, some unknown factor. If we multiplied by that, we'd get their actual ages. So we could say that Adam's age would be 5x, and what was his name? Ben's age would be 7x, and when we add 1 to those ages, the ratio then would be 8 to 11. Okay, so that's how I would start off this problem. Once I get that equation, then essentially once I've figured out that step, I feel like I've solved it already, because I'm confident that I can solve that equation for x because it's one equation with one unknown. Okay, so let's go ahead and solve it. So from this step, I would cross multiply this expression, or this expression by 11. So 5x times 11 is 55x. Rub that out. 1 times 11 is 11. 7x times 8 is 56x. 1 times 8 is 8. Keep on simplifying. Subtract 55x from the right hand side. We would have 1 lot of x. And then 11 take 8 is 3. Okay, so x is 3. Remember what x is though. That's what we multiplied this original ratio by. So if we multiply all of these by 3, I get 15 to 21 to 33. Go back to the question. How old are they all now? Well, their ages are here in this ratio. 15. So Adam is 15, Ben is 21, and Caleb is 33. And you could check this. If you added 1 to each of those, we'd get 16 to 22 to 34. And then that simplifies, if you divide that by 2, that simplifies to 8 to 11 to 17. Okay. Alright. That is almost all of the questions. I think I only ended up skipping one. Okay, so let's go ahead and check we got these correct. This is always good practice. Make sure you check your answers. And I would do it this way. I would firstly do all of the questions, then check your answers afterwards. Sometimes I'd change it up. If you're unsure of a topic, maybe do like one question at a time, checking your answers as you go. But if you're pretty confident with a topic, do them all at once and then check your answers after you've done all of them. Okay, where are we? Question 1, 9 circles. Question 2, 3 to 5. Question 3, 2 to 15. Question 4, I think we skipped. Question 5, 72. Question question 6. By the way, shout out now if there's any topics that you'd like me to talk about after I check these, because yeah, I don't have, well, I have one other problem I could pull up, and then other than that, if there's nothing else that anyone wants to go through, then it'll probably be the end of the stream. But if there are things you want me to go through, then I'm here, and yeah, I'll hang around. I've got actually well, I've got about another hour to live stream, but you know, I'm not going to be live streaming if nobody needs any help with anything. Sorry, but let's keep checking these. 6 was 22%. 7 was 1 lipstick. 8, Zaki says cosine rule. Circle theorems. Check out my video on circle theorems. I go through all of the circle theorems with proofs. So check out my video on my channel. It's actually the top video on the front page. So yeah, I don't know what, like, if you're after the proofs, I went through all the proofs you need in that video. Question 8 was a long one, was 9 to 8 to 4. Excuse me. Question 9 was 43 to 60. I was worried I got that wrong, so yeah, good. 10, 49 to 78, and 11. That was my answer there. 15, 21, 33. Okay. Let's see. Someone said cosine rule, which Zaki's okay. I wasn't saying, like, I wasn't trying to be insulting there. I was just saying, like, I'm not sure what else I could say about the circle theorem proofs. That's all. I didn't mean to be rude there. Sorry if that came out wrong. Yeah. I'm just not sure what else I would add to that video. Yeah, I'm not sure, like, with the general topics, like, I noticed Suraji said probability. Oh, but just to finish this point, it's kind of difficult to start a lecture on probability, if that makes sense. So sorry. Yeah, like, maybe if you had a specific question, but I don't have anything prepared for that right now, so it's a bit tricky. But Blue Snow, you were saying, if you're still there, you were saying one of the questions from the 2019 paper. So let's see. If I have that available. Okay, so I'm just, was it the June 2019 or? Okay, 2019 paper 1, hopefully. May, so the one in May. Was this the right one? Alright, let's see. So was this, I think I went through this question 22. I think I went through this in a separate video. Okay, so if I find this question, I'll do this one, then another problem solving question I have, and then I guess that will be it. So question number, could you give me a question number? Oh, so it's not this one. So you think it's not this one. Right. Okay. Hello, Tio. Thank you for all your compliments. Very much appreciated. Just don't know what to say to all of that stuff. That's all. If you don't mind, let me find. Oh, see. Okay. So that was question 22, not question 22, not 21. That's on functions. Not this one. Question 16 about a lock. Um, 12 is about spheres. Also, thank you for the likes. 24 likes already. That's awesome. Thank you very much. Appreciate it. The lock one. Okay. Could give this a go. Alright, let's see. Whoa. Not sure why that came up. Sorry. Alright, anyways. Okay, let's do something and then I'll do another problem, then that'll be it. Okay, alright, so this one says there are 3 dials on a combination lock. Let's make this a bit bigger. Three dials on a combination lock. Each dial is set to one of the numbers 1, 2, 3, 4, or 5. The 3-digit number 553 is one way the dials can be set as shown in the diagram. Work out the number of different 3-digit numbers that can be set for the combination lock. Okay, so if, oh, whoops, I haven't got a way to write. Okay, alright. Apologies for the disorganization. I should have something prepared. I had those ratio questions prepared, but there we go. Okay, so work out the number of different 3-digit numbers that can be set for the combination lock. So if I've got 5 possibilities for each one, you can think of this as how many possibilities in each space. And, well, 5 possibilities here, 5 here, 5 here. We're doing 5 times 5 times 5, 125. So that would be my final answer there. Part B says how many of the possible 3-digit numbers have 3 different digits. Okay, oh, this is actually kind of, oh no. So, well, if we've got, actually this isn't too difficult. If we've got 5 possibilities in the first space, we could use 1, 2, 3, 4, or 5. Then if we use, say, 1, for example, we have only 4 possibilities left for the second space. And once we've used, let's say we used 1, 2, or yeah, 1 and 2, how many possibilities left for the last space? If we want to use all 3 different digits, there would be 3 possibilities left. So then the problem becomes 5 times 4 times 3. So final answer there, 60. So that was 125 for A, 60 for B. Okay, so paper 2, question 17. All right, let's see if we can pull that up. Paper 2, question 17. All right, is this the right one? Okay. There are some small cubes, and even if it's not the right one, I'm doing this one now. Okay, question 17. There are some small cubes and large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4 to 7. The ratio of the number of red cubes to the number of yellow cubes is 3 to 5. Great, so this is a ratio. This fits in with today's topic. Awesome. Explain why the least possible number of cubes in the bag is 88. Okay, so we're talking about objects, so we need a whole number of those. And we have small cubes to, actually we could write S to large cubes equals 4 to 7. And then red cubes to yellow cubes equals 3 to 5. Okay, so what's the total here? This is 11 parts. 11 parts in this ratio. And what's the parts here? This is 8. And they both need to have a whole number of small and large cubes and red and yellow cubes. So we're looking here for the lowest common multiple of 8 and 11. So that would be my reasoning. I would say probably the lowest common multiple of 4 plus 7 and 5 plus 3 is 88. That would be my reasoning there. I can't actually write on this because this is a PDF, but hopefully you get my point. Next part, all the small cubes are yellow. Work out the least possible number of large yellow cubes in the bag. Okay, so we have a ratio here of red to yellow of 3 to 5, and we also know that all the small cubes are yellow, so this would be like saying, we could rewrite this as yellow cubes to large cubes. So actually let's write this down here. Okay. So then that becomes like a similar problem to what we were doing previously. We have two ratios. two ratios and we're looking for, and we have one common element between those ratios. So we want to combine them. So we want red cubes to yellow to large cubes. The common multiple between 5 and 4 would be 20. So this would be, multiply this one by 4. This would be 12 to 20. This one by 5. 12 to 20 to 35. So then what could we do then? Actually, is this... Oh. I don't know if that was the correct approach. All right, what am I doing? I've had a bit of a brain fade. Work out the least possible number of large yellow cubes in the bag. If all the small cubes are yellow cubes. So we have a fraction of small cubes, which is 7 out of 11. And oh, yeah, that's where I went wrong. So that's not saying that all of the yellow cubes are small cubes. Kind of made a mistake there, a logical error. Not all of the yellow cubes are small cubes, all the small cubes are yellow cubes. So we could still have more yellow cubes that are not small cubes. So we could have 7 over 11, which is the fraction of large cubes, subtract some amount, would be what? That would be the number of red cubes we have left. So, oops, okay. Wow, I got really stuck on that for some reason. So the multiple of, so there is some multiple of 88 cubes in the bag, I guess, and the fraction of those that are, should finish this off. The fraction of those that are large yellow cubes is 23 out of 88. Wow, Blue Snow, you really got me on that one. Apologies for that terrible explanation. I'm going to have to get back to that question and explain it better. Yeah, kind of failed on the ideas behind that one. Good question. I'll have to get back to that. Yeah, that's a good one. Okay. Yep. Okay. All right. Well, I think that is a good place to finish. I think any other problems after that will be probably easier than that I have. All right. Yeah, I didn't explain that at all well though. I can't right now. I can't think of an easy way to explain that, how I solved it. But there you go. Any other topics quickly before I go? Completing the square. What? Yeah, okay, completing the square. I was just going to say that's a funny topic to kind of bring up. I was just watching a video on completing the square. I don't believe this is factorizable. 5 and 3. No. So to complete the square on this, firstly you factorize the 2 out. 15 divided by 2, 7.5. And then you complete the square on that quadratic. So you pretty much always factorize before you use completing the square. And then look at this quadratic. You look at half of the coefficient of x. That becomes your second term in your squared brackets here. And then you square that second number, so 1 squared is just 1, and you subtract it. Is it add or subtract? I always forget. Well, to make it equal, it would be, yeah, subtract 6.5. So then double check, expand that out again, we get x squared plus 2x plus 1 plus 6.5. Simplify that, you end up with x squared plus 2x plus 7.5. So the steps that I always follow is to, if there's a coefficient of x squared, factorize that. Then complete the square on the quadratic that you have. But to do that, you take half of the coefficient of x, that's your second term, the bracket, square that, and then subtract it from the constant. So there's a fairly standard set of steps you can follow to help you with that. All right, I am going to go and have a close look at question 17, because that was a good one, and maybe make a video on it. or possibly work on the videos that I'm working on. So I'm looking to do a full set of walkthroughs of the 2019 papers, full set of walkthroughs for the A-level 2019 papers, and yeah, that's it at the moment. So I'm looking to make those videos hopefully by March or the end of March. So that's the main thing I'm going to be working on. Oh, this, yeah, you could finish this off and multiply by 2. You could do 2x plus 1 squared plus 13, I guess. You could write it like that if you want. But yeah, so that's what I'll be working on. Live streaming tomorrow, so then you can throw more grade 9 questions at me and I can completely fail on live stream like I just did. And then live streaming Friday as well, hopefully. Alright, thank you very much for tuning in. Leave a comment if you want, let me know what topics you want to do in tomorrow's live stream. Other than that, see you in the next one. Bye for now.